Good morning, everyone. Welcome to the New Features in Geomatica 2015 webinar. Thank you for joining us today. Geomatica is a powerful geospatial image processing software suite used by professionals, researchers, and students around the world for fast and accurate image analysis and production. Geomatica provides visualization tools, support for the latest satellite and aerial sensors, and over 550 algorithms to manipulate and extract information from imagery and related geospatial data. Geomatica provides powerful workflows for ortho mosaic through OrthoEngine and automation capability with our open source Python API, easy scripting language, and modeler graphical interface. In this one-hour webinar, you'll learn how Geomatica's new color balancing methods produce more accurate and consistently pleasing results for better mosaics. You'll see how you can adjust the brightness and improve the visibility of lost details with new exposure correction tools. And you'll find out more about the Geomatica platform. Python functionality has been improved by handling arrays, which means direct access in Python to rasters and bitmaps for custom workflows and applications. All this, plus new sensors, speed, and interface improvements. We'll review all of those items and continue with a live demonstration. The presenters today will be Sean Malamed and David Pickney. I'm David Pickney. I'm the Product Marketing Manager for PCI Geomatics. And Sean Malamed is one of our pre-sales application specialists. If you're not seeing Sean on the road at one of our many trade shows or events, you can find him in our offices in Markham, Ontario, Canada. I'm located there as well, working closely to put these webinars together and provide great products for you. All right, so the agenda today, we'll start with an overview of Geomatica 2015. We're going to be looking at the new and the updated features that you see here. We'll continue with a live demonstration of the new mosaicing color and color balancing technology. And we've saved some time at the end of the webinar for questions and answers. Okay, so let's start with the overview of the new items Geomatica 2015, then the new items, and then get into that demonstration. So what is Geomatica? Well, it's many things to many people. We're talking about powerful image analysis software with robust, accurate, and fast optical and radar analysis. These are industry-leading tools and include things like pan sharpening and atmosphere correction with use in many industries and applications. We have a number of different interfaces. We'll talk about one of those in particular today, the Python interface, which was introduced in the last version of Geomatica and has been greatly expanded in Geomatica 2015. So let's start by taking a look at mosaicing in Geomatica 2015. As an overview, there have been two main areas of improvement in Geomatica 2015, the automatic methods and the manual QA tool, and manual color balancing options. You can see the main items here. There's a new algorithm for the color balancing. This is called bundle. We expect this is going to be replacing the nearest neighborhood or other methods that people are currently using, providing consistently good results. We also have automatic exposure correction. I've got some demonstration of that coming up, as well as a couple of points here about automatic cut line selection, where we've got better pathfinding and simplification as well. So taking a look at the first option, or the first new automatic method, the automatic color balancing, new algorithm has significant advantages of treating each edge, cut line, between images separately. So where the previous algorithms would provide a single set of coefficients to adjust an entire image, which means that the brightness, contrast, and hue were adjusted for the image as a whole, the new method, shown at right, uses a set of multiple coefficients to adjust individual images. So things like image brightness, contrast, and hue are now adjusted not only image by image in this global method, but for each edge independently, and then blended together. This means you get very, very accurate color responses in a fully automated workflow. The second item I mentioned was the exposure correction. That's what we're looking at here. So if you take a look on the left, you can see that there are some areas which are completely oversaturated. You cannot get any image detail out of these very bright white areas. In this particular case, we're talking about high reflectance from concrete or very light colored surfaces, aluminum surfaces. And using the exposure correction, again, it desaturates these areas and brings out those image details. So on the image on the right, where this correction has been applied, you can now see the individual planes on the tarmac, you can see the buildings, you can see details on the runway. But if you look at some of the dark areas, for instance, the river in the lower left-hand side or the dark asphalt on the runways, we're not darkening the entire image. We're just bringing out the detail in those very bright areas. So we're maintaining the image integrity, but providing more information and a more pleasing image as well. As I mentioned, also the cut lines, we have improved pathfinding, and the simplification and the smoother, shorter cut lines reduce your quality assurance, quality control time, makes errors easier to identify and easier to correct. Now there's also some interactive mosaicing updates that have been included as well in Geomatica 2015. The most important of which is the dodging points. So what are dodging points? Well, Geomatica 2015 comes with this new powerful interactive tool for editing dodging points, which are used for localized color correction. So you can see an example of the one on the screen here. With multiple overlapping images, there's a point highlighted with the blue border around it, right in the center. And we can see that the image on the left is too bright, whereas the image on the right has the proper color correction applied, or color exposure applied already. We're able to select which image we'd like to work on, the left side or the right side, and then we can adjust the brightness, the contrast, and the color of whichever side we're working on in a localized area without affecting the entire image or the entire project. So these dodging points extend Geomatica's mosaicing capabilities and they allow you to create better mosaics than before. Two types were added, the edge dodging points and the floating dodging points. Edge dodging points are along image borders, whereas the floating points can be placed anywhere within an image manually to adjust any local color. As I mentioned, it's not just the brightness and contrast that can be adjusted, it's also the individual color channels. So if an image in this case was too red, we can turn down that particular color. We can adjust any of the colors independently or in combination. Right, we've also added a simpler, improved lookup table editing interface. So this provides a more intuitive way to adjust the appearance of your image in Mosaic. In this case, we're looking at an entire mosaic, or perhaps an image that you've imported into Geomatica 2015 for editing. It makes it very easy to adjust the color, the brightness, and other image features to get that, that specific output that you're looking for, making a great looking product. Okay, moving on now to another one of the areas of improvement in atmospheric correction in Geomatica 2015. So we've now included a dynamic atmospheric modeling tool. This allows for easy comparison between target images and a known reference, thereby indicating model accuracy. This provides significant improvement to ATCOR capabilities and ease of use, as you can now compare the spectral curves calculated for the image to a large reference library. So the atmospheric parameters that can be modified with immediate feedback include things like adjacency distance, atmospheric correction, aerosol type, visibility, and height. And you can see by comparing a point within your existing image to that reference library, you're able to see how well your parameters have been selected and matching. If you've got a good match between your model and the library, you know that you've got excellent parameters for use for atmospheric correction within that image or those images. All right, let's take a look now at Aero triangulation. We have new support and we have integration with third-party bingo package for AT as well. So starting, we have automatic multi-image GCP collection. So not just stereo collection, but any number of overlapping images. We now have single control points that tie all of those images together with the reference, as opposed to a pair-based approach only. So this goes beyond simple stereo collection, as I mentioned. This improves blunder detection, and there's also new error detection for flight line orientation in Geomatica 2015. Not only improve the GCPs, or ground control point collection, but also the tie point collection. So this improved tie point collection and the multi-image GCP combined are applicable to satellite or aerial projects. Both help you create fast, accurate models. In this case, the improved density and location of the tie points helps tie together the entire project, giving you very high relative accuracy. So when we combine this with the multi-image GCP collection for your absolute accuracy, we find a very fast collection of very accurate points, producing a very good model for your projects. As I mentioned, this is both for aerial and for satellite. Here's a satellite example with 3 overlapping images and the reference applied. Just as a recap, this does create a more robust model. It gives you a better surface model, which in turn improves your orthorectification and the final accuracy of your mosaics. Another item that's been greatly improved in Geomatica 2015 is the Python API, or Application Programming Interface. This allows you to program in the Python scripting language using Geomatica libraries, Geomatica functions, so you're able to integrate third-party libraries with Geomatica spatial technology and write scripts that automate and improve or expand the capabilities of Geomatica. Allow you to produce these, put them together, really customize the work, and bring in that geospatial component and all of those Geomatica functions. Now, Python was adopted as a programming interface in Geomatica in 2014. But in the 2015 release, you can see the new access and objects that we've added. This means you can program and call information directly from the channels within the imagery. Masks, metadata, GCPs, right from segments. We can extract the elevation values and do elevation modeling on those channels directly, as opposed to requiring a third-party library to process those points. So as mentioned, Python allows users to more easily integrate the Geomatica software functions and objects with other commercial and open source software and libraries. And these low-level access and objects we've provided access to allow powerful and custom models to be created. In addition to the interface and the functions, the help is greatly expanded. We have high-level functions and descriptions that are available directly in the PCI help menu, and these include descriptions and usage of the 550 plus algorithms, similar to the modeler or the algorithm library. And also improved help for the low-level Python functions that we've added. This is included in a new API reference manual. There's additional usage tips that are available online, as well as a point on or a page on GitHub where we're able to share information and tips with other users and programmers. All right, new sensor support. As you know, PCI is dedicated to providing models, rigorous and RPC models for new satellites, commercial satellites as they're launched. Here's a list of some of the new satellites. You can see some commercial, some optical, some radar. And in addition to the either adding these new sensors or improving support for metadata of the existing sensors, we've also included at-core support for new sensors. So the first 4 on the list here, Worldview 3, ZY3, GF1, and FastSat Charlie, now have support for at-core as well. Okay, now I'm going to turn things over to Mr. Sean Malamet, who will spend some time actually demonstrating the features that I've described, the mosaic and color balancing improvements, as well as some of those graphical processes I just mentioned.
Well, thank you very much, Dave. That was a wonderful introduction to the new features and improvements that we've made in Geomatica 2015. And so in this demonstration, we're going to focus mainly on the mosaicing side. And as David mentioned, we did a lot of updates to a variety of different packages, such as our atmospheric correction package, as well as our ortho rectification capabilities with improved GCPs and tie points, additional support for Python. These lower level objects is going to make modeling significantly easier and significantly more powerful than what we had available in our previous package. But one of the areas that we really spent a lot of investment and a lot of development effort on in this current release is our mosaicing side, and this includes both automatic color balancing methods and cut line methods, as well as new manual editing tools. So we're going to focus on these particular aspects of our release. So I'm going to take you on a quick tour where I'm going to highlight some of the new mosaicing algorithms and interactive tools now available in Geomatica. So Geomatica is already known as a leading technology for creating beautiful mosaics, but these new developments continue to demonstrate PCI's ongoing commitment to excellence, particularly in the orthomosaicing area. So with color balancing, one of our most exciting new mosaicing algorithms in years that we have released is this automatic color balancing method known as bundle. This method uses a completely new approach for creating seamless mosaics while maintaining amazing color fidelity, which gives you that natural look that people ultimately want. So before we go a little bit into the algorithm and show you how actually running this algorithm, let's just take a quick peek at some of the results that we were already able to generate with this method, using a variety of different types of data. So this first image that I'm showing on screen shows air photos, a high resolution air photo imagery, where you can see that we have this ramping effect going from left or right to left or left to right, depending on which orientation you're looking at it. And this ends up creating, for the different flight lines, a very poor color balancing effect. So this is something that we are able to now correct very nicely with this new bundle method. And you can even see that when we switch to our results, that the color in the water is even much better balanced as well. And then if I were to use the editing tools, we could easily finalize this mosaic. So if we just zoom into another area in here, we can see that if we toggle on and off, that we can effectively remove the visible seams from our mosaic. Now just go into some satellite imagery here. We have some ComSat imagery that was collected on different seasons, different dates, so each one of these orbital strips is collected on a different date. So this makes it very challenging for many color balancing algorithms to correctly handle this kind of imagery. So obviously there's a disparity in the histograms, which is why we see a significant contrast in these different orbital tracks. But our color balancing, the bundle method, is able to handle that well. And as you can see, we get a significant improvement in this overall region. Now this is a small area. What happens when we try to do something like a country-wide mosaic? So here we have a countrywide mosaic that we produced from Landsat imagery, and we got imagery from a variety of different dates, different there's seasonal variations within this mosaic. We also have a variety of different land covers such as snow, ice, forest, barren land, urban landscapes, water, etc., that our color balancing algorithm has to take into account. So if we look at here, this is what we get without color balancing, and then when we apply our color balancing algorithm, not only do we get a well-balanced mosaic that's better than anything we've ever been able to achieve before, but we also get the color fidelity, so a nice pleasing aesthetic looks that we're hoping to achieve. Here's just a few more examples. So we have a rapid eye over North Korea. So once again, we get a very nice dynamic mosaic where we have the seams have been effectively removed. And this last one's quite interesting because we're using a combination of Worldview 2 and GeoEye imagery. So even when we're creating mosaics from multi-sensors, we're able to handle that nicely with this color balancing algorithm known as bundle. So what makes the bundle so special? Well, if we look here, I just have a couple quick slides to try to better explain. And David did a very good job of explaining this as well, but I'm just going to reiterate some of this. So basically, the bundle algorithm is helping to solve this particular problem. Basically, as David mentioned earlier, our previous color balancing methods and color balancing methods in many other packages use a single set of coefficients to adjust the color, the contrast, and the brightness of images. And what this often creates is a situation where you get an image that might balance well to some of its neighbors, but then doesn't balance well with other neighbors. So what our algorithm helps to do is it basically treats each edge separately and can actually create a gradient effect within the image. Now, we try to hide the gradient effect so that you actually don't see any visible gradient, but what this does is it basically creates a situation where you don't have any obvious or difficult seams to have to approach in an editing environment. So to better explain this, here we have a small block of images with different colors, and basically what our color balancing algorithm is going to do is it's going to take each edge and compare and analyze each edge to its neighboring images, and then adjust the colors of that, and then have a nice transition as we go through and create that sort of gradient effect. Now, as I said, I show this gradient just for illustrating the concept. Obviously, when we create our mosaics, we want it to be as seamless as possible. So you should not really see a gradient effect in your actual mosaics. But this, I believe, gets at least the concept at a high level across as to how this color balancing algorithm is different from the rest. So now that we have that, let's actually go into a project where we'll run the color balancing algorithm. So we're going to run it on this set of imagery here, which is actually Iconos imagery, but we've downsampled it to a much coarser resolution so that we can process it, very quickly for this demonstration purposes. The idea that we want to process it in, say, 20 seconds instead of a couple minutes. So let's go into this project. I'm going to bring up OrthoEngine. So in this example, we've already created our orthos, and we're just going to proceed to the mosaicing step. So we go to the processing step, mosaic. We can click on Define Mosaicing Area, which is going to allow us to choose our region of interest that we want to include in the mosaic, as well as select the images that we want to include, and set up other information. I'm just going to browse for an output file, so we'll just call this webinar mosaic. We'll click OK. So now our file is defined. Then we can go to our last button here. So in case you didn't see that, I clicked on this button here. This is going to go to our automatic mosaicing panel, which allows us to set up our color balancing options and our cut line options, etc., etc. So I'm just going to change my starting image to one of the more centered images. And then for color balancing, I'm going to choose the method. The default method now is bundle. And just in case you couldn't tell, the reason we called it bundle is because our approach for correcting imagery or for applying this color balancing is kind of similar to the concept of performing a block bundle adjustment in a photogrammetric domain. So we'll use our default cut lines, and we're just going to now generate the preview. So this is going to generate a low resolution preview of this mosaic that we can then directly go into the interactive editing mode and review and perform any editing that might be required. Okay, so we have our mosaic has been generated. It shows us a quick preview here, which we will come back to in a moment. So we'll just close this. And now I'm going to go to our second button here, which is the manual mosaicing panel. This is going to allow us to go into interactive mosaic editing mode. So this will allow us to adjust the cut lines and the color balancing. And this is where I'll be able to expose two of our new interactive editing tools known as edge dodging points and floating dodging points, which will significantly improve your ability to create a beautiful seamless mosaic and significantly reduce the amount of time that it will take to get to that result. So we can see here, we can just quickly review from a high level. We'll just get rid of the labels. So we can see from a high level that it did a good job of generating our color balancing results. Obviously in the water there's areas that we could touch up. But this is a challenging mosaic because we have cloud, we have haze, we have a variety of land cover types, seasonality differences, we have water, etc., etc. So we're going to take a look at, I think for this particular mosaic, the color balancing was very very effective. But let's go down to an area, so we'll put our cut lines back on for a moment. We're going to go down to an area where we can further improve. So if we look here, we can see that there is a bit of a issue with this mosaic over here. So what we want to do here in this case, we'll just put the cut lines back on just so you can see, is we want to improve the seams on this between this image here and this image here, but we want to make sure that we don't negatively interrupt the seams or affect the seams between these two images. So using a traditional approach, you would be forced to basically increase the color of the entire image or the brightness of the entire image. So maybe if we wanted to get it to fit well, we might have to lower the whole image, but now we've introduced seams over here, and so this is no good. So what we can do to get around that is these new dodging points. So this is also what the automatic color balancing does too. It puts these dodging points on each edge and defines a set of coefficients for each of them that it has analyzed to be the best to create a color match that's ideal. So here now I can just simply take this one and I can decrease the color, and it's just going to apply it for this cut line. And I can use these tools as well to do large steps or very small steps to get to that final result that we might be looking for to create that seamless result. Now it gets even more powerful than that. So for example, over here we can see we have a similar problem, but the difference is that it's very localized. So if we zoom into this area, you can see that up here around this region, if we put our cut lines back on, you can see that it's well balanced over here, but then we introduce some problems around here. So what we can do to effectively fix this is we can click on our edge dodging point, and we can now add a new edge dodging point. As you can see, it snaps to the cut line. So we can add one over here to create that as a blocking point. We'll use this one that's already there as another sort of wall or an area to block, and I'll put one in the middle. And now with that one selected, I can actually choose either this one or this image here. And we can decrease just this part without affecting the other areas of our seam. So for example, I can now go into I can select our edge dodging point, and now I can say decrease the brightness of this one until we get, and we can remove our vector until we get a nice seamless result that we're looking for. So we can also click on this image too if you wish, and if we say we wish to just increase the brightness over here. So now we can get to that final look without having to do a lot of editing in different areas or without affecting other regions. So it allows us to get to the finish line much faster than we were ever able to do before. Now another concept that was introduced is this concept known as floating dodging points. So we have an image here where, say, the image overall is too dark. So say we want to just increase, say, the brightness of this image without really affecting the other parts. Well, I can put a floating dodging point on that image, and then I can adjust the brightness of that image, and it provides a nice radial gradient around it. Now, same thing is true with these. If I want to just say work on a very localized region, I can set up a bit of a wall here, put one in the middle, and then I can just increase, say, the brightness of that area. So we'll increase it significantly so you can see it working. And as you can see, these other ones act as a barrier to prevent it from spilling out into the surrounding pixels. So this is just some of the new methods, color balancing, and interactive editing tools that have been introduced into Geomatica 2015. Okay, so Let's move on to the next area that I want to discuss, which is our desaturation, or sorry, our exposure correction tools, which allow us to basically reduce the brightness of overexposed pixels. So what I'm going to do here is I'm going to apply an enhancement at this level to both our input image, so this is the full resolution mosaic, and the exposure can be exposure correction is applied to the mosaic after we've generated it. So it's a post-editing process. And we're going to apply the same enhancement to our result image. So we've already generated our result. And what it's going to show you is that, say the lookup table that we're using right now is the one that we prefer to use because it's overall the nicest one, but as a result, very bright areas become oversaturated or overexposed rather. So what we can do is with our new exposure correction algorithm, it runs on this tool and it helps to remove these overexposed regions, or lowers the brightness of these overexposed regions, creating more contrast and more detail. So if we just go to another area, so say we go here, this is another nice example. So this area is kind of similar to before, where we're just going to get more detail, but I really love what happens over here at the baseball diamond. As you can see, it's very washed out, gives you more of this white appearance, but after the exposure correction, we get that yellow brownish soil that we would expect of this region. So I particularly like that area. So it actually brings out the color better as well, the natural color. And the nice thing, as I said, is when you look at the two, you really don't get any major effects in the darker pixel areas, or you don't get really any effects in the darker pixel areas, as the algorithm is intelligent enough to just scan the imagery to look for large overexposed regions. So now how will we set this up? Well, we can go to Tools, Algorithm Librarian. We can go into our new tool sets, and we can look for the desature. So the desaturated image, which is probably better known as exposure correction. So we can open up this, and we have two input options that are mandatory. So we have the input reference image. And actually, just to simplify this, let's just remove our result. We'll go back into the tool. So now we only have the one image. This is the one that we want to apply the correction to. So we set up these input channels for the reference, and then for what we want to actually apply the correction to is our same file. So the reason why we have these two is that if you have a mosaic that's tiled, well, you can generate the preview, the low resolution preview mosaic, say from OrthoEngine like I did earlier, and use that as your reference image, and then you can provide your tiles in here. And this way it's going to actually be able to apply the the exposure correction to tiled mosaics, which is a very nice feature. Here you can then provide it as to show it to viewer or save it to disk. And then, as we do with many of our algorithms, we like to provide you with some parameters so that you can tweak different areas to try to get that final look that you're going for. But the defaults for the most part work exceptionally well. So we probably didn't even need to provide these parameters, but we like to give our users the options to play and tune with the different parameters so that they can really get that final result that they're looking for various images. Now I'm not going to run it, as it's going to take about 3 minutes to run, and we don't need to watch a progress bar for 3 minutes, as you've already seen the results. But this is basically how you'd run it. You would generate your mosaic and then simply run that desature function on your output mosaic. Alright, so this is going to lead to one of our final demonstrations. So we're going to go back, and another area that we've improved with regards to mosaicing is our smart geofill. So for those of you who've been to our booth on the road when we're attending trade shows, or for those of you that we've actually visited in person, you might already be familiar with our smart geofill from our previous Geomatica 2014 release. But in this case, what we've done is we've actually made some very nice improvements to it to make using this tool even more effective and easier. So this is the tool where we really believe can help, this along with our other tools, we really believe can help minimize users from having to use non-geospatial software packages to fine-tune their mosaic So we're hoping that you can stay within a software package such as Geomatica, which is more tuned and more is developed to really handle the kind of data that we're dealing with. So in this case, we're just going to remove this popcorn cloud and the shadow, and we're going to remove it from. So we're going to, our input image is a a GeoEye image, a QuickBird image, and the pixels that we're going to be using to replace it is ComSat3. So we're going to set our source, the ComSat3 says we're going to copy the pixels from, and then our destination is going to be the output QuickBird image. So I have an empty vector layer here, so I can simply draw a polygon. We'll just do that a little bit better. Around our cloud in the haze area. And at this point, now that I have my layers set up, I can go copy, which is going to, the first thing, as you can see, it's going to put this very white pixel here. Now, it doesn't always do that, but the reason it's doing that actually exposes one of the other benefits of this tool, is that we're working with 16-bit data, which have very different ranges. So let's just very quickly take a look at the histograms. So we can take a look at the red channel histogram for our QuickBird image and compare that with the red channel histogram of our ComSat3 image. So when we take a look at both side to side, you can see that for this window, we have a very similar looking histogram. However, the range itself is very different. So our ComSat3 image has a range of about 1,000 to 6,000 DN values, whereas our QuickBird image has a range of about 300 to approximately 500 or 600 DN values. So there's almost an order of magnitude difference between the range of these two histograms, which explains why our pixels are overexposed in this area. So to handle this, we've now introduced our color balancing options. So we can go to histogram trim, and we can set our match width to be a little bit bigger. We're going to set a trim percentage to be a little bit higher because we have clouds. We can click apply, which is nice because it's going to show us what this will look like without actually pasting the pixels in. So here we can see that we now get a much more similar looking colors and histogram for this region now. So if we're happy with this, we can now say just simply go paste, and it's going to automatically resample the imagery, so they're different resolutions, reproject them if they're in different projections. So it's going to handle all that on the fly. So I paste it in, and it's going to apply a blend width to really minimize the appearance of any seams that may be introduced. So let's just remove our polygon and the copied layer. Let's just shake it up a bit. And then when you come back here, you really cannot see any visible seams. And this was challenging 16-bit imagery that we're working with very different dynamic ranges.